In this video, we are going to learn how to calculate the orbital speed and orbital period of a satellite. The question says, assume that a satellite orbits the Earth 225 km above its surface. Given that the mass of the Earth is 5.97 times 10 to the power 24 kilogram, and the radius of the Earth is 6.38 times 10 to the power 6 meter, calculate the satellite's orbital speed and calculate the satellite's orbital period. Let us first write what the question has given us. They have given me the distance of the satellite above the Earth's surface. And whenever this distance is given above the Earth's surface, we write this distance as h, which is 225 kilometer. And I will convert that to meter by multiplying this with 10 to the power 3. Then they have given me the mass of the Earth, 5.97 times 10 to the power 24 kilogram. I have the radius of the Earth, RE, equals 6.38 times 10 to the power 6 meter. So in part A, we have to find orbital speed, and in part B, we need to find the time period. The rule for orbital speed is given as V equal square root capital G M over R, where capital G is the universal gravitational constant, M is the mass of the Earth, and R is the distance of the satellite from the center of the Earth. So this small r in the rule for V is the distance of the satellite from the center of the Earth. Center of the Earth to the satellite. So this distance r starts from the center and goes until the satellite. Question has given me the radius of the Earth and the distance of the satellite from the surface of the Earth. I can calculate the distance of the satellite from the center of the Earth by adding these two values. So my small r will just be addition of RE plus H. And we can calculate the value of small r before solving for V. Then I will put my small r equals 6.38 times 10 to the power 6, which is RE, plus 225 times 10 to the power 3, which is H. That gives me the value of R as 6.6 times 10 to the power 6 meter. This is the R that I will substitute for my equation for orbital speed and orbital period. Let us solve for V. I will write square root. G is 6.67 times 10 to the power negative 11. Mass of the Earth they have given us 5.97 times 10 to the power 24 divided by the distance of the satellite from the center of the Earth. And when you solve this, you get the value of V as 7764.5 meter per second, which you can also write as 7.76 times 10 to the power 3 meter per second. Second part of the question wants me to find the orbital period. And the rule for orbital period T is 2 pi square root R cube over capital G M. Let's substitute for that. 2 pi square root. Again, the R over here is the distance of the satellite from the center of the Earth. So this is the R that we are going to use. 6.6 times 10 to the power 6 cube divided by G, which is 6.67 negative 11 times mass of the Earth. And when you solve this, you get your time period as 5338.8 seconds. This is my time in seconds. I can convert that time in hour by dividing this value with 60 times 60. Because every hour has 60 minutes and every minute has 60 seconds. And when you do this, you get the time period of the satellite as 1.48 hour. So whenever they give you distance of the satellite from the surface of the Earth, you need to first calculate the satellite's distance from the center of the Earth by using this rule. Small r equals radius of the Earth plus h. Then you can use the rule for orbital speed and orbital period to get your values. Let's discuss another problem. A geosynchronous satellite is one that appears to remain over one spot on Earth. Assume that a geosynchronous satellite has an orbital radius of 4.23 times 10 to the power 7 meter. Mass of the Earth is 5.97 times 10 to the power 24 kilogram. Calculate its orbital speed and period. First, let us write down what the question has given us. Notice that in this question, they have mentioned this as the orbital radius. And when they say orbital radius, that means this is the distance from the center of the Earth to the satellite. This is my small r. And I don't need to do any further calculation to do r. This is what I will take as r. So the difference between the previous question and this one is, in the previous question, they had given you distance of the satellite from the surface. And whenever it is from the surface, you have to find r by using re plus h. But here they have mentioned orbital radius, which is my distance from the center. So in this situation, I will not modify my r. I will take whatever value they have given me as my distance r. So r is 4.23 times 10 to the power 7. Mass of the Earth is 5.97 times 10 to the power 24. And they want me to find the speed v and period. So let's use the same rule for v. Orbital speed v is square root capital G m over r. You can substitute for G as 6.67 times 10 to the power negative 11. Mass of the Earth is 5.97 times 10 to the power 24 divided by the distance r. And when you solve this, you get the speed of the satellite as 3068 meter per second. Or you can write this as 3.07 times 10 to the power 3 meter per second. Then we calculate the orbital period E, which is 2 pi square root r cube over gm. 2 pi square root r here is 4.23 times 10 to the power 7 cube over G is 6.67 times 10 to the power negative 11 times the mass. And when you solve this, you get your time as 86624 seconds, which you can convert to hour again by dividing this number with 60 times 60. and that will give you 24 hours. So a geosynchronous satellite is the one whose orbital period is synchronized with the rotation of the Earth. This is why it has a time period of 24 hours, same as the rotation of the Earth. When you're calculating orbital period and speed, the m over here in both cases, the m does not depend on the mass of the satellite. It only depends on the quantity which is at the center. So if Earth is at the center or any other planet is at the center, this mass is the mass of the planet and not the mass of the satellite. So if the question asks you, what happens to the orbital period or what happens to the orbital speed when you double the mass of the satellite, your answer should be that it is not affected.